Hi everyone, I'm Neerad. I work at Meta on the Presto team as a production engineer, and I've been involved with this team for about 3 years now. Uh, so today we are gonna give a short lightning talk on how we added a new feature to Presto to so that it can better utilize elastic compute. So some motivation and some definition on what elastic compute is. So as we know, Presto runs pretty well today on guaranteed capacity, where the workers are guaranteed to stay in the Presto cluster. And even when they need to be replaced, there is a mechanism to like drain them and wait for them to complete their workload before they shut down. And because of this draining feature, we can prevent query failures on guaranteed capacity. At the other end, we have elastic capacity where workers in the Presto cluster are replaced without being allowed to drain. And this can lead to query failures as it stands in Presto because the workers will not be able to complete their existing workload and we do not support recoverability in Presto. So Presto is not fault tolerant to sudden worker preemption to reliably run in this sort of scenario. Between these two extreme scenarios, there is a middle ground where we have elastic capacity where the workers in the Presto cluster are expected to be replaced at a particular point in the future. So each worker in the Presto cluster has an expiry time or a time to live, TTL. And at this expiry time, it will be replaced without being allowed to drain. So you can think of this, it's something similar to the Amazon EC2 spot blocks feature, where you are allocated opportunistic capacity for X number of hours. So this time to live or a TTL based scheduling was developed to support this particular use case. So how does this work? The basic idea is to rely on query execution time estimates to pick the appropriate cluster and the appropriate workers within a cluster to execute a query. As you know, we have a mechanism where we can provide resource estimates when launching a query, and execution time is one of those resource estimates. So the scheduling is done at two levels. So each cluster provides a cluster level TTL at the cluster/TTL endpoint on the coordinator. This information can be used by any load balancer sitting in front of a bunch of these elastic clusters to route the queries to the appropriate cluster. Uh, Once the query reaches a cluster within the cluster, the query is scheduled to run only on those workers whose TTL is good enough. So what do we mean by good enough? This basically means that the TTL of these workers is greater than the estimated remaining query execution time. So if I have 10 workers, five of them with like 15-minute TTL and another five with like 3-minute TTL, and a query comes in which is expected to take like 10 minutes maybe, then the coordinator will only pick those five workers which have a TTL of 15 minutes because it knows that these workers have enough time to complete this query. So what are the interfaces that we have for this feature? So there is one, the TTL fetcher. This is responsible for collecting the TTL for each worker in the cluster. You can imagine this might reach out to an external entity which tells you that these hosts or these workers are expected to stay with you for X number of minutes or hours. We then have the cluster TTL provider, which is responsible for providing a cluster level TTL at the aforementioned endpoint. Like I mentioned, this can be utilized by a load balancer to pick the appropriate elastic cluster to run a query on. The cluster level TTL can just be something which is derived from the individual worker level TTLs. We have an implementation for a percentile based cluster level TTL where it looks at the like maybe let's say 20th percentile TTL of all the workers and represents that as the cluster level TTL. Then we have the simple TTL node selector class, which is responsible for selecting workers for execution based on the TTLs and the query execution time estimate. And yeah, so putting all of these together in a diagram, this is a high level view of how it can work. So as mentioned, we have the TTL fetcher manager, which in turn invokes the TTL fetcher interface to fetch the TTLs of all the workers from some external TTL provider service. This then feeds into the cluster TTL provider, which can utilize the individual worker level TTL estimates to provide a cluster level TTL estimate. And this cluster level TTL can be utilized by the load balancer in conjunction with the query runtime estimates for routing across different Elastic clusters. Once the query actually reaches the coordinator of a coordinator of a particular Elastic cluster, it can then utilize the simple TTL node selector to pick the appropriate workers to schedule the query on. For completion, we just show the discovery node manager and the discovery node server, which feed into the TTL fetcher manager to provide the list of workers that are available to the coordinator. This is it for a high-level view on the TTL-based scheduling. I'll now hand it off to my colleague Abhishek to talk about how you can provide your own implementations for the TTL fetcher and the other interfaces listed, and the different configurations you can deploy them in.
Hi everyone, I'm Abhishek. I'm working as a software engineer at Meta in the Presto team. Now that you have learned what a TTL scheduler is, let's see what we can do for the integration. So integration is pretty simple. You just need to create a custom Presto plugin and implement these two interfaces. So TTL fetcher interface provides a method that returns TTL information given a set of nodes. So in the implementation, you may want to integrate with your service or utilities that returns TTL information given a node. So now, once you have the plugin ready, so you just need to configure that plugin to be used in your deployment. So for that, you can define no TTL fetcher factory in this property file in order to define the fetcher implementation. So you may have like multiple fetcher implementation. So you can define whichever one you want to use for your deployment. So in order to use TTL-based scheduling for a query, you can pass this session property, resource-aware scheduling strategy, as TTL in the query. And once that query lands on a coordinator, and coordinator will use TTL-based scheduling to schedule that query. And in case if it is not present in the session property, then there's a fallback logic to use the strategy from experimental.resource-aware scheduling property. So in a way, you can use this configuration to configure your entire cluster to use TTL-based scheduling. So just to demonstrate how end-to-end would look like using TTL-based scheduling. So let's say a query comes with execution time estimate as 10 minutes and resource-aware scheduling as TTL. Coordinator will select workers that have availability to execute this query, which may take like 10 minutes. So as you can see in this diagram, coordinator did not pick worker 2 because it has TTL 5 minutes, which is not sufficient to execute this query. So this is majorly what we have done for Elastic Compute. Moving on to our future work, to give you some context, at Meta currently we have multiple smaller Presto clusters within each data center. So having these smaller Presto clusters introduce a lot of limitations. Particularly for Elastic Compute, there could be scenarios when an Elastic Compute cluster does not have sufficient workers to execute a query. So we have to mark the entire cluster offline. Apart from that, having smaller clusters introduce resource fragmentation and also operational overhead. So in order to address these limitations, so we are thinking about a future where we can have like much bigger clusters with the support of multi-coordinator capabilities. So as a step towards that direction, we are thinking about mixing Elastic Compute worker nodes with dedicated worker nodes within the same cluster. So current resource group and memory management is not designed in a way to support this multiple workers of different capabilities within the same cluster. So we are working on to revamp this resource group and memory management in order to support this kind of setup. Also, we are thinking about introducing worker pool concept. So as you can see in this diagram, so we have this cluster consisting of an elastic compute worker pool containing elastic compute nodes, and then we have a dedicated worker pool containing dedicated worker nodes. That's all we have for today. Thank you.